Everybody, Mr. Pat from Kailua Boys and Girls Club. I'm going to see if we can fire this up and try to run my iPad in this at the same time with a backing track, play along to it, have some fun here. If it works, it's an old Elvin Bishop song with remix, rewrite the lyrics. Okay, let's see what happens. Feels like I've been here about 1,000,000 years. Wanna meet all my friends at the park. Give 'em a hug, I wanna shake their hand. Not go home till after dark. I wanna fool around and have some fun. I fool around though I might get bummed. I wanna fool around and have some fun. Fool around and have some fun. I see a blue sky the way it used to be. We'd meet at the park and just play, play, play. Or if the wind was good and a swell came in, well, we'd all just surf all day. We wanna fool around and have some fun. Fool around and have some fun. But if we fool around, we might get bummed. We wanna fool around and have some fun. Here we go. A little early there. I see a blue sky the way it used to be. We'd meet at the park and play, play, play. Or if the wind was good and a swell came in, well, we'd all just surf all day. We wanna fool around and have some fun. Fool around and have some fun. We wanna fool around, but we might get bummed. Fool around and have some fun. Have some fun. Fool around and have some fun. All right. Yeah, not bad. Okay. Kill that. Put that stuff down. Takes a lot to get this going here. Okay, again, Mr. Pat from Kailua, Windward, Oahu. Boys and Girls Club. We're Gonna run a math lesson for you now. Thanks for, kind of hard to play the karaoke, a little bit different version, but it worked out okay. I just started the solo too soon, but who knows, right? Okay, I'm gonna switch this screen, and what you're gonna do is you're gonna see stuff from yesterday. So if you weren't part of yesterday's lesson, it might not look familiar. You can always go back and check that out. Kind of a tripped out thing. You can Google it and learn a bunch of stuff about these Mersenne primes, perfect numbers. Mersenne prime, Father Marin Mersenne figured it out. I'm going to spin this so you can see what I'm talking about. Okay, we created this table, and we found that Mersenne primes are a perfect way to find perfect numbers. And what we learned was, in this table with this configuration here, when the 2 to the nth power minus 1, I know that sounds all mathematical, but that's all right, it is. When this is a prime number, this table produces a perfect number over here. And these are the numbers that if you add all the factors up except the number itself, it adds up to the original number. So that's what the significance of perfect number is. Okay, so I want to blow your mind a little bit. So that's the first Mersenne prime, 3. The second one's 7. The third one's 31. The fourth one's 127. The fifth one happens to be, 8,191. Here's what's insane. This is the most recent one found, and this is just a small part of it. I was looking for a poster, I couldn't find one. So check this out. Those digits are not the number. There are 22 million digits in a number that goes in this column. It's like the 39th Mersenne prime. I mean, you already found 4 of them. The 29th has something like 60,000 digits. The 39th has 22 million numbers in it. You can't even put it on this. The font would be too small to see. Okay, it is insanely insane. And what's even heavier is that's the number in this column. And it's going to multiply by whatever's in this column to produce something even bigger, the perfect number that goes with it. So try to wrap your brain around that as you focus on these kinds of things. It's just insane. And what they do is, this was found at UCLA, and they run, it's humans checking everything, running computers that run computers and whatnot. But there's people that do this for a living. Some do it just for fun. Some do it because they get paid to do it. So you can Google as much as you want if you have interest there. But try to wrap your brain around a number that this is just the tiniest little speck of 22 million digits. Crazy. All right. So I'm going to erase all this, and as I do, I'm going to talk about today. So I know I promised you a lot of graphing with quadratics and whatnot, the stuff you're going to miss from your algebra classes being canceled, and it's got a lot of basic skill stuff in it, and we will get into that quadratic graphing. That's kind of a whole thing all by itself. But I want to review just normal graphing, because you guys have been out of school, and you will have been out of school for quite a while. So I want to spend some time going over graphing different types of functions. So the first one, I'm going to do this just real quick. In the very first lesson, I talked to you about something called an exponential function. And the reason I did that was that's what was showing up in a lot of that coronavirus stuff. And basically an exponential function starts out real gradual and then goes up super rapidly. So the way it changes is very small, 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 and then it just skyrockets into oblivion. And that's what all the data you were seeing about the corona was doing. So it was meaningful stuff. Fortunately, that's leveling off a little bit now for us. So we're not going to talk anymore about that today. We're going to talk about the one you guys are familiar with. Okay, so today and tomorrow, we're going to talk about linear functions. And function, in your mind, you can just think this. Okay? So linear is basically the word line is in there. And that's the giveaway for what a linear function is. So linear function is a straight line. So I'm going to make myself here for us to use. I'm going to make a graph. An XY axis. And I don't have graph paper, so I'm just going to do this. I'll try to do this without making a mess here. Okay. So we've got our arrows. These are our axes. This is the x-axis. This is the y-axis. Okay. And I'll go ahead 1, 2, 3, 4, 5, 6, 7, 9, 10. This is why people use graph paper. They don't have to do this. I'm going to use it to just kind of remind you of there's actually 3 really good ways to graph linear functions, and I'm going to go over each of them. Probably just 2 of them today, and then the 3rd one tomorrow, because it's probably the one with the most application. Okay, so if you got graph paper, that's the way to go. You don't got to do what I just did. So a linear function, it's going to be a straight line. It might be pointing up, remember that positive slope, might be pointing down, negative slope, might be really steep, might be gradual. You can even have them straight across like that. So we're going to show you, remind you of 2 ways to do that. And the first way we're going to use, I'll put the title of it, is the first way you use is a T-chart. Or input, output table. So sometimes, I'm just going to show you, sometimes you see them in your examples like this. And what they do is they put the X and the Y, and then they have their things going out like that, and they give you the numbers. I'm not going to do that. We're going to do the ones where you are the creator. Okay. So this is the simplest one. When you're going to use a T-chart, the simplest way to do it is just go like this. This is X, this is Y. Okay. And we need an example. So we're going to start with an equation, a function. And I think for that one, what I'll do is I'll write right down here. We'll go y equals 2x minus 5. So you're going to graph that. In order to graph that with a T-chart, you need 3 ordered pairs, 3 xy coordinate pairs. So when you use a T-chart, usually, if you got y by itself especially, you pick an x and you plug it in and see what y you get. Okay, so I'll go ahead and I'll use color coding for that. So I'm going to pick an x, and let's say x is 3. So what that says is I'm going to say y equals 2x plus 5. Minus 5. So what I'm doing is, where the x thing is, I made a box so I can put different values. I'm going to put a 3 in there. So I'm picking x. You can pick whatever number you want. Just pick it small enough to fit on your graph. 2 times 3 is 6. 6 minus 5 is 1. So when x is 3, y turns out to be 1. That's the coordinates 3, 1. So there's your ordered pair right there. The x, the y. So you need 3 of those. So if 3 worked, you might say, well, dude, why not 4? Let's try it. So I put a 4 in here. Okay, 2 times 4 is 8. You don't write 8 there. And then 8 minus 5 is 3. So when x is 4, y is 3. And you can continue on that line, or you can get tricky if you want. Some students like to challenge themselves, see if they remember their skills. So let's get fancy. Let's say I did x is -1. Whoa, dude. So if I put a -1 in here, I have to be very careful. That's why it's more of a challenge. So that's -2 minus 5. Remember that? -2 minus 5 is plus -5. I'll make that change so you can see it. So plus -5, same thing. Leave change opposite. So when x is -1, y is -7. So this is a good way to practice your basic skills. And here's how you know if you did it right. You're going to plot those points, and they should form a straight line. If they form a triangle or something off like that, then you didn't do it right. So we've got these 3 points to plot. So I'm going to come over here and do that. So let's say 3, 1. So I go 3 over and 1 up. That's about there. 1, 2, 3, 1. 4, 3. 1, 2, 3, 4. And then I go up to 3, if I'm doing that about right. And then -1, -7. Remember that if it's negative, you start and go to the left. So I go this way. And then I go 1, 2, 3, 4, 5, 6, 7. So I'm down about here. Okay, so the good news is that looks all right. So when I line this up, it's a little harder to do without graph paper. It's a little easier to do with graph paper. So I go like this, and I draw through that. It connects in a straight line, so I'm confident I did a good job. And then you can write the equation along there to tell people what you graphed. And so you go y equals 2x minus 5. Okay, awesome. All right, so examples are important. So we're going to do another one. So we're still doing T-charts. And this time I'm going to start with example 2. I'm going to say x plus y equals, you ready? 7. So that's a little different. Y is not by itself. Some students get thrown off by this. It's actually a very, very, very simple thing. This is why T-charts can be extremely helpful. The other ways may or may not help. Check this out. If I ask you, give me 2 numbers that add up to 7, all of you could do that. You could say 5 plus 2. So when x is 5, y is 2. There you go. 5 plus 2 is 7. Pow. You could say 3 and 4. X is 3, y is 4. 3 plus 4 is 7. Dude, easy. You're like, oh, that's all? That's right. Always got to do 3. You can use 0. What if I use x is 0? Then I got to add 7 to it. Okay. So really simple. Sometimes it looks hard because it's different, but it's not. So we're going to do the same thing. I'll graph this one in green so that it's a different color. So 5, 2, 1, 2, 3, 4, 5, 2, about like that. Okay. 3, 4, 1, 2, 3, 1, 2, 3, 4, somewhere around there. Oh, looks like around there. We got that. And then 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So this time, well, my 3, 4, I'm a little messed up on. Okay, I got it here. This one was x plus y equals 7. And then remember, this also teaches you something, reminder about the slope. So this is called a negative slope. The one's pointing downhill. The red one is positive slope going uphill. Kind of a trip. Okay, another thing that's super cool is check out the point right here. That's on both lines, right? So check it out. The 1, 2, 3, 4, 1, 2, 3. So this point is 4, 3. If you plug it into this one, 4 plus 3 is 7. And if you plug it in here, 2 times 4 is 8, minus 5 is 3, it works. So this is the solution to these two. It's the only point that's on both lines. Just threw that in. Okay, so T-chart's a great way to do linear functions. Okay, so remember that. Don't ever forget it. It's something you can fall back on and use whenever you want. Okay, I'm going to erase that, and we're going to jump into our other way. Not T-charts anymore. This is the one most often forgotten. Boy, I miss my smartboard, I gotta tell you the truth. Yeah, I want you to focus on something here. I'm gonna erase all this to get it out of your way. I want you to look at these 2 points right here. Okay, this is the x-axis. This point right here is called the x-intercept. Now, if you look at the coordinates of it, 1, 2, 3, 4, 5, 6, 7, 0. So this x-intercept, those are the coordinates. I want you to think about that for a minute. This is the x, this is the y. It's on the x-axis, which means you don't go up or down at all. So the y value is 0. So one of the tripped out things about this thing called the x-intercept, where it intercepts the x-axis, is it's the y-coordinate that's always 0. If you were right here, it'd be 2, 0. If you were right here, it'd be negative 3, 0. But on every x-intercept, the y value is 0. Your teachers wrote that for you when you studied this. Look at this point. I don't go right or left at all. And then I go up 7. This is the y-intercept. I'll abbreviate intercept. Now check it out. This one's a trip. At the x-intercept, the y value is 0. At the y-intercept, the x value is 0, because you don't go right or left at all. You're stuck here on the y-axis. So you can use that to graph. One of the cool things about graphing with the intercepts is you don't need 3 points, you only need 2 of them. And a lot of times they're very easy to find. So let's do examples. So every y-intercept, x is 0. Every x-intercept, y is 0. Okay, redoctor my line. Yeah, baby. Real human being right here trying to get you a good lesson. Okay, so we're going to graph using x and y intercepts. And what do we need? An example. Okay, you guys ready? All right. So we're going to do 4x plus 3y equal negative 24. You write that down. Now, if you had to graph that with the t-chart, it'd be a pain in the butt. But we're going to show you how to do it. So if you look back at this video, what I told you was every time you have an x-intercept, the y value is 0. So what you're going to do to find the x-intercept is you're going to put a 0 where the y is. So you're going to go 4x plus 3 times 0 equals negative 24. So I know that every time I'm on the x-axis, y is 0. So I'm using that to find the x value here. Because 3 times 0 is nothing. So it goes away. So I end up with 4x equals negative 24. Easy equation to solve. As long as you don't lose your negative sign, x is negative 6. So I got my x-intercept. My x-intercept is negative 6, 0. So I go 1, 2, 3, 4, 5, 6, and there it is. And you're going to do a very similar thing for the y-intercept. I'll do that up here in green. So for my y-int, what I'm going to do is I'm going to, every time you have a y-intercept, you don't go right, you don't go left. Okay, so the x value is 0. So on this one, I am going to put 0 where the x is. That disappears. I got 3y equals negative 24. Divide by 3. And I get y equals negative 8. So my y-intercept, okay, you ready? Is 0 for the x, because it's the y-intercept, so it's the x value there. I know that's a little weird. So in this case, I don't go right or left at all, and I go 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And that's all I need. Okay? So now what I do is I draw my line, and I'm in there. Oh. Sorry about that. Okay. So that right there is 4x plus 3y equals negative 24. So what you're looking at here is you set x to 0 and you find the y-intercept. Because x being 0 means you don't go right or left at all. So you're on the y-axis. You set y to 0 and you find the x-intercept. Because you don't go up or down, so you're on the x-axis. And that's the other way to graph. Okay, with Classroom, I'd show you more of those. Maybe we can practice one at the start of tomorrow's lesson. Then tomorrow I'm going to do slope-intercept, that mx plus b thing, and we'll go from there. I'm not going to play any more music today. Okay, I'm just going to say aloha. So Mr. Pat from the Windward Boys and Girls Club, a little bit longer music. It's fun to do that. And nice, valuable lesson here. We'll touch base again with a slope-intercept graphing, and then pretty soon we'll get in the quadratic stuff. Okay? Good to see you. Hope you guys are tuning in and taking some time to learn some stuff here. It's there for you. Share with your friends if you like it. Mr. Pat, Kailua Windward Boys and Girls Club, aloha.